Well, hello. Ho am Melon. My name's Joe. People call me Mr. Melon. Welcome back. So, on this video, this is going to be video note for paper 3, the angles of attack. Today I decided to shoot this one a little bit differently. We're on location. So, we are at a park. I do have to give a quick shout out to the Foundation Academy. They've been around since 1988. You can Google them or look them up in Jacksonville. They are doing a science fair, I guess, for the last couple of days. So great opportunity to come out and I remember when I was a kid, I loved science. So I did the whole refraction, pencil in a cup of water thing for my science fair. It brings back memories. And apparently the Science Foundation Academy, they take a real hands-on approach to teaching kids. It's wonderful. Great to see. With kids like this, our future's in great hands. So, quick shout out, there was a little wizard there. He was so excited to talk about isopods. It was great. It was him and his little crew did a good job. Little pill bugs, crustaceans, very helpful to our environment. Help God. They're God's little recyclers. They'll eat anything. So another booth was talking about deforestation, important. Black holes made it too. That was a good one. They talked about what black holes are, what we know so far. They didn't have as in depth of an understanding, but that's okay. They'll get there eventually. There was a little thing. Somebody made a Lego Mars rover. That was cool, and it was automated. You didn't even have to do anything. It just did its little task that you programmed into it, and I didn't even know they had Legos like that. They didn't have that kind of stuff when I was a kid. There was a thing on supernovas that was pretty cool. Somehow he also got on the topic of radon gas leaking into our environment from uranium. So I don't know how those two things exactly we're going to correlate in his presentation, but good job nonetheless. Mycelium network communication, how funguses communicate, and how good they are for the soil. And they did a little experiment. It was great. It does show that having mycelium and different mushrooms in your garden will make a healthier garden. That's just how that goes. So there was a thing on dark box photography, some of the oldest photography in the world. Pretty much just a photoreactive piece of paper or material, put a box around it, make a little pinhole, you can make a picture of an old style camera. So they did a whole thing on that. It was pretty cool. The placebo effect. The placebo effect made the science fair. So why is there a placebo effect in the first place? And why is it only what we see it to be and not something different? Those kids didn't have an answer, but that's okay. Nonetheless, the effect is real, and they went over that they actually do see the placebo effect. And not only that, but then they went into psychosomatic things where, like, you empathize with somebody and your thoughts kind of make you a little sick, queasy your stomach, things like that. How does that exactly work? So they went over that, but it was pretty good. They had a thing here for the manatees right next to the water. Makes sense. But our manatee population has bounced back considerably since the guy who they were from Jacksonville University. So, but he said the population's grown up to 400,000 or something to that nature, down from just a few thousand. So definitely good work there. Possibly looking into laying down more vegetation for them. They had a die-off a while back for the manatees. They didn't have enough food, but they eat vegetation in the water. So we could technically just plant them some food. So, but he did say that was one of their solutions they're working on. The bonobo kiki effect, that was a neat little thing on communication. When you see a certain object, your mind will relate what you see to what you think it should be named. So that was kind of neat. The Mars rover is the one who got the ticket for me because they were doing a ticket thing. But yeah, I really like that. That's space and rover technology in action, and now with Legos. So All right, with that being said, 5 minutes of that's down. We're going to go ahead and go into part one, the defining what an angle of attack actually is. So when you think of what an angle of attack is, think of it this way. Airplanes fly, their wings are moving through air at a specific angle of attack to generate lift. Okay, so this you can find, this section we're going to go over. It's found on page 62, section 29.1. And really, this is going to explain why there's only three and not more. But that being said, the foundation of this particle generations is the geometric interaction between a particle's trajectory and the vacuum's lattice grain. Now, we operationalize this with a Finslerian interaction, defining the angle of incidence between the particle's four velocity vector. So the angle that it is moving in space relative to the grain of space itself. The governing equation for this is equation 170 in the paper. In case you haven't looked it up there you go. Let me go ahead and look at the camera, unlike one of my other takes where I was looking at the opposite side instead of the camera. So, all right, part two, the three flow regimes. This you can find on page 64, section 30. There are exactly three stable regimes of flow before a hydrodynamic system breaks down into chaos, which maps perfectly into three particle generations. Generation 1, laminar flow. It's got a parallel alignment to the grain of space. What it is, it's just not displacing space the way the other regimes do. So it's really close to a zero angle with the lattice. The result, minimal mass. The electron represents the path of least resistance. It just flows as it was moved initially. Generation 2, the muon. It has an intermediate 45-degree angle. Some other things that have a 45-degree angle, the strange quark, the charm quark, and the bottom quark. They all have 45-degree angles as well. And the result's intermediate mass. The muon's heavier because it pushes a turbulent wake, eventually decaying into a generation 1 configuration to minimize drag. So, generation 3. This is the tau and the top quark. Straight cavitation, yield. They end up hitting the lattice grain at a 90-degree angle. It goes straight in. The lattice is something. It can only go so far. So that 90-degree angle, the trajectory impacts the lattice broadside. It's a dynamic pressure. Once it exceeds the 10 to 11th giga electron volts for the QSM yield point, then what it ends up breaking down and its space fills up. That's it. But it's trying to push back. And so what it is it saturates it, and it represents the energy required to physically fracture the metric, resulting in cavitation. And that's one reason why it's so short-lived, because the vacuum itself is something, so it pushes that cavitation back. If there's not enough mass there to sustain that cavitation, it will decay and bounce back. The effective volume is governed by equation 192. That's this equation right here. V is the base lattice volume, and then the string is the topology factor. The electron volume, its minimal angle of 0.1, its displaced volume is vanishingly small. 2.65 times 10 to the negative 59 meters squared, or cubed, making it appear to be a point particle. The muon, it's a 45-degree angle, 4.67 times 10 to the 56 meters cubed, times 10 to the negative 56 meters cubed. It exceeds the total or the local elastic limit, and it triggers immense mass. I skipped over the muon, I'm sorry. That's 45-degree angle. It displaces roughly one full vacuum cell, 1.10 times 10 to the negative 56 meters cubed. And again, this is all located in my paper. Read it. There's two different versions. One that's 108 pages. The other one, 66 pages, that's double columned with all the lines numbered. You can find those in the you can find them on the description of my page and download them for free. So, a fourth generation. Why is there not a fourth generation? Well, page 64, section 30.4. To explain why there's only three, we apply the Zermelo limit from the Rander's geometry. The bound, the metric is only positive, definite, if the the drag vector is less than the speed of light. A hypothetical fourth generation would require a geometric coupling of sin greater than 1. This mathematically triggers a dielectric breakdown and vacuum cavitation immediately. It's going the wrong way. So space has properties. What this does ultimately lead to a prediction. The tau lepton 0.8267 femtometers. Now, when they took the proton radius measurement, they initially found two different sizes. Then they redid the measurement using a different experiment type, and they matched up. That's exactly what they should have seen. When you alter the space behind the measurement, it's going to affect the geometry of the overall picture. They don't look at the background as anything, so they're missing that part of the picture. But that's fine. My paper goes through that as well. So, but it makes a specific prediction for the tau lepton when they get to that level, and when they can figure out how to actually precisely take that measurement along with the board into account. It's, again, 0.8267 femtometers. Neutrinos, 0.12 electron volts. They are small. That's why they don't really interact with anything. They don't displace anything. They're just moving through the lattice with ease. Antimatter has the inverse of the angle of attack. So, for instance, a strange quark's antiparticle would have also another 45-degree angle, but it would be the other 45-degree angle. So it's just the opposite. And it's relative to the grain of space itself that ultimately makes that function. Composite proton mass, stable quark, top quark decays almost instantly because it doesn't have any other geometries, and they're balancing it out with the grain of space and the pressure of space itself. So the composite proton overcomes that property and now has a way to float through space stably. So, what a day. Anyhow, thank you for watching, and I appreciate all the support. Yeah. Our future is in good hands. Look at this little science fair. It's great. There's so many people. All science enthusiasts doing different projects, learning about God's project and His world. Outstanding. So, until then, though, may peace be with you. Ho Aeon Melon. And y'all have an awesome day. Stay blessed.